So today's lesson is over trapezoids and kites. Want to give you guys a couple reminders before we do that. First of all, that you guys should have turned in the circuit activity today, the one we did out in the hallway earlier this week. And next week, we have our mock midterm on Monday. We're going to review for our Unit 4 test on Tuesday. We're going to take the Unit 4 test on Wednesday. We're going to review for the county midterm on Thursday, and then we're taking the county midterm on Friday. So before we move on, I want to kind of go through this warm-up just to reiterate what our properties are. So our properties of a parallelogram are opposite sides are congruent, opposite angles are congruent. And the reason I didn't put parallel on that first one is because that's part of the definition. Then our diagonals bisect each other. And our consecutive angles are supplementary. Okay. Then when we're talking about the properties of a rhombus, it includes the properties of a parallelogram plus, obviously the definition of a rhombus is all four sides are congruent. And then diagonals bisect the angles. And the diagonals are perpendicular to each other. And these are all those things you should have known for that quiz that we just took. So these are a couple examples of some practical applications for trapezoids. Notice the baskets have the shape of a trapezoid, and so do the jump boxes. Today our objective is to prove that a given quadrilateral is a trapezoid or a kite and to solve for the missing parts of trapezoids and kites. So this is our vocab. We're going to talk through each of these. Trapezoid is quadrilateral with exactly one pair of parallel sides. The legs of a trapezoid are the non-parallel sides of the trapezoid. The bases are the parallel sides. And the base angles are at either end of the bases. So let's look at this drawing here and then you'll understand. So trapezoid is a quadrilateral with exactly one pair of parallel sides again. So BC, notice up there, and AD are parallel because they have arrows on them. And we call those the bases because they are the parallel sides. And then the other two sides are the legs. So I want to talk to you all about the base angles now. So in trapezoid ABCD, one pair of base angles are A and D. So we're talking about these angles down here, A and D. Those are a pair of base angles. And then we've got angles B and C, and that's because they're at either end of the base. And in addition to that, we have a couple properties I want to talk to you about here. The angles at the ends of the legs are supplementary. Now I want to talk to you about why this is true. So if we look here, we have this parallel line here, and we have this parallel line here, right? Then we have this transversal. And if I talked about angles X and Y, hopefully all of y'all can see that those are same side interior angles. They're on the same side of the transversal, and they're inside the parallel lines. And if you recall back from earlier this year, that same side interior angles are supplementary. The other property that applies to this is that the sum of the angles in a quadrilateral is 360 degrees. So, the properties of our non-isosceles trapezoids are that only one pair of opposite sides are parallel. The angles at the ends of the legs are supplementary. And the sum of all the angles in a quadrilateral is 360 degrees. So now we're going to actually use these properties. So here again, we're going to talk through what kind of relationship. So notice JK is and ML are our bases, which means KL and JM are our legs. So when we add our angles at the either end of our legs together, we get that they are supplementary. So I can subtract the measure of angle L from 180 to get the measure of angle K. So when I do that, I get 129 degrees. Same way over here to find for M. So again, once again, we've got these legs here. This is a leg here, and this is a leg here. When we talk about those, the angles at the either end of them, when we add them together, they should be 180. So here again, I'm going to subtract J from 180 to get the measure of angle M. So that one was 93. On this next one, again, notice we've got this leg over here, AD, and we've got this leg over here, BC. So once again, we're going to subtract 31 from 180 to get angle C. That's 149 degrees. And then we're going to subtract 62 from 180 to get the measure of angle D. And that's 118. Now on this next one, it's a little bit different only because our parallel sides are not horizontal. So here again, I'm going to go from one parallel side to the other. That's our leg right there. So that means we're going to add 54 to 8x plus 6 and set that equal to 180. That's 60 plus 8x equals 180. Subtract 60 from both sides. 8x is equal to 120. Divide both sides by 8. X is equal to 15. And the way we could check that is by plugging it back in. So 8 times 15 plus 6, that's 126. And when we add 126 to 54, that equals 180. And that's how we can check our question. So here's some more properties. We're going to talk about the isosceles trapezoid now. And an isosceles trapezoid is a trapezoid where the legs are congruent. We're also going to talk about this term mid-segment, and it's the segment that connects the midpoints of the trapezoid's legs. So first of all, I know that this is an isosceles trapezoid because AD is congruent to BC. And if it is an isosceles trapezoid, I also know that the base angles A and B are congruent, and D and C are congruent. So if a trapezoid is an isosceles, then the pair of base angles are congruent. If trapezoid PQRS is an isosceles, then angle A is congruent to B and C is congruent to D. Here again, we have an isosceles trapezoid because side AB and CD are congruent. And if that's the case, then the diagonals are congruent as well. So we know that AC and BD are congruent. Our next property is, we've already done this one once, but we're going to review it again. So this time this is isosceles trapezoid again because AD and BC are congruent. Still here at the ends of our legs, the angles at the ends of our legs are going to be supplementary. So 120 plus 60 is going to be equal to 180, and 120 plus 60 is going to be equal to 180. So A plus D and B plus C. Our last property has to do with the midsegment. EF is the midsegment in this drawing. AB and DC are bases. All three of these, AB, EF, and DC, are going to be parallel. Also notice that I know that E and F are midpoints of AD and BC because AE is congruent with ED and BF is congruent with FC. So when we do this, we're going to add our two bases together and we're going to divide by 2 to get the length of our midsegment. So I want to show you this with some numbers because I think you guys do better with that. So if this top base was 2 and the bottom base was 4, it would stand to reason that EF would be somewhere between 2 and 4. So what we're going to do is add those two bases together and we're going to divide by 2. So that's going to be 6 divided by 2, which is 3. And this is a logical answer, obviously, because the top base is 2 and the bottom base is 4, and 3 is between those two numbers. Here's the other piece that I want to discuss with y'all. That AE is half of AD, and that's because we see tick marks on AE and ED. So if we knew that AE or AD was 4, for example, then we would know that AE and ED would be 2 and 2. Same way, BF is 1/2 of BC. So once again, if we knew that BF, let's say this was 4, then we could say that BC is 8 because each piece of this would be 4 and 4, and the whole thing would be 8. So now it says find the measure of angle QR and the measure of S and QR. Okay, so Let's just talk about QR first. I think on your paper that you had that PS is 5, which means QR is also 5, right? Then we have that the base angles here are congruent because this is an isosceles trapezoid. So we know that P is congruent to Q, so that's going to be 112. And we know that S is congruent to R. Well, you should know here that P and S are supplementary because they're at the ends of a leg. So I can subtract 112 from 180 and get 68 degrees for S. And recall that S and R are congruent as well. So R is also 68 degrees. So let's look at this next problem. It says if MNOP is an isosceles trapezoid, then we know that MP and NO are congruent. We also know that the diagonals are congruent. So MO is congruent with NP or PN. So when we set these up to solve for X and Y, we're going to say MP is equal to NO. We're going to substitute in our equations, subtract 9x from both sides, add 13 to both sides, divide both sides by 7, so X is equal to 3. Then we're going to set PN and MO equal to each other. That would be 5y plus 19 equals 12y minus 37. Going to subtract 5y from both sides and add 37 to both sides. That gives us 56 is equal to 7y. Going to divide 56 by 7, so y is equal to 8. And the properties we used here were that our legs were congruent because it's an isosceles trapezoid, and that our diagonals were congruent, again, because it's an isosceles trapezoid. So on this one, it says ABCD is an isosceles trapezoid again. So I'm going to put some arcs here, some tick marks, and then I'm going to put arcs down here and here because these are the things that I know are true of an isosceles trapezoid. Well, obviously, if that's the case, then I should know that angle D and C are congruent or equal. Then I can substitute in my values for those. Again, subtract 2x from 5x, add 12 to both sides. 3 goes into 39 13 times. Now, to find the measure of angle C and D, I just plug that 13 in. So that would give me 53 for angle C and 53 for angle D. And that should be the case. And if it's not, then we know we got the wrong value for X. Now to find A or B, I just subtract 53 from 180. Because when I add those two angles together, they have to equal 180. So I'm going to subtract the 53, and that would be the measure of both A and B because we know that A and B are congruent. All right, number 7. This one again says it's an isosceles trapezoid, so we know this is true. The base angles are congruent and the opposite sides are congruent. So this time I need to solve for X and then plug X back in, obviously. So what I notice here is that W and X are congruent, which means that I could put this 10x plus 5 over here. And that means then that I can add angle X and Y together and they should equal 180. So that's exactly what I'm going to do. I'm going to combine my like terms, 10x and 6x, that's 16x, and 5 minus 1 is 4. I'm going to subtract 4 from 180 and divide 16 into 176, so X is 11. Now what I need to do is plug it back in. So I'm going to plug it into the equation for W, which would be 10 times 11, that's 110 plus 5, that's 115. And then we know, obviously, that W is equal to X, so X is also 115. Going to plug that 11 into for angle Y as well, so that's going to be 6 times 11, that's 66, minus 1 is 65. And we know that Y is congruent with Z, so we know that angle Z is also 65 degrees. Okay, so now we're going to talk about this mid-segment. I know that X is a mid-segment because we've got these congruent. This is going to be a midpoint and that's going to be a midpoint. And I know that because of my tick marks on the left and the 2 tick marks on the right. This is what tells me that X is a mid-segment. So our formula was mid-segment is equal to the base 1 plus base 2 divided by 2. So I'm going to say X, which is my mid-segment, is equal to 18 plus 48 divided by 2. That's 66 divided by 2. and that's 33. All right, number 9. This one's a little different because our mid-segment here again, here's our midpoint and our midpoint of our two sides. So this time our mid-segment is 15. So we're going to say 15 is equal to x plus 22 divided by 2. Now, here's the thing that you guys need to remember. When I have a 2 in the denominator, the way I get rid of it is that by multiplying both sides by 2. So that's what I'm going to do here to go ahead and get rid of that 2. When I divide both sides by 2, that 2 over there goes away, and I'm going to end up with 30 is equal to x plus 22. Subtract 22 from both sides, so x is equal to 8. Number 10, PQRS is a trapezoid. Y is the midpoint of PS, and Z is the midpoint of RQ. So that means this is congruent with this, and this is congruent with this. And that also tells me that YZ is my mid-segment. So I'm going to set 5x minus 19 equal to 38 plus x plus 14. I'm going to multiply both sides by 2 again, and I'm also going to combine my like terms. The 2's are gone from there. So I'm going to end up with x plus 52 and 2 times 5x minus 19. That's going to be 10x minus 38. Distribute the 2 to both of the numbers inside the parentheses. I'm then going to subtract x from 10x and add 38 to 52. So 9x is equal to 90. Thus, x is equal to 10. Then I have to plug that back in to solve for my two other parts, SR and YZ. So 10 plus 14 obviously is 24, and 5 times 10 is 50, minus 19 is 31. And we can check this because if we were to add 24 to 38, that would be 62, and half of 62 is 31. This last one, again, this time we just have 3 equations. And again, we have to be able to recognize that this is our mid-segment here, VW. So we're going to say VW is equal to RS plus UT divided by 2. So here again, we're going to get rid of that 2, and we're going to combine our like terms. So we're going to multiply both sides by 2. And we combine the 2x and the 6x, that gave us 8x, and we're going to subtract 37 from 15, that gave us negative 22. By distributing that 2, we get 6x plus 10. Then we're going to subtract the 6x from the 8x, and we're going to add 22 to 10, and half of 32 is 16. Now, once again, we're going to plug this value in for RS, VW, and UT. So RS is 47, VW is 53, and UT is 59. Here again, if we want to check this, we would do 47 plus 59 and divide that by 2. 47 plus 59 is 106, and half of 106 is 53. And that is what we got for that measure. All right, so now we're going to talk about a kite. Kite is a quadrilateral that has 2 pairs of consecutive congruent sides, but opposite sides are not congruent in this one. So notice here we have AB has 1 tick mark on it and CB has 1 tick mark on it. AD and CD have 2 tick marks on them. Over here on the right, MN has 1, and MQ has 1, and NP and QP have 2. So here we go. Let's talk about the properties. So if a quadrilateral is a kite, then its diagonals are perpendicular. Notice that there's a right angle in here at X, which means honestly all 4 of those would be right angles. So we have 4 right triangles, important, and we're going to use that in a few minutes. So if quadrilateral ABCD is a kite, then KT is perpendicular to IE. Also, when we have a kite, if the quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. And these angles are between the 2 non-congruent sides. So notice that AD and AB are not congruent. and DC and CB are not congruent. So those angles that are congruent are between the non-congruent sides. The last one, the last property, is the diagonals that intersect the congruent angles in a kite bisected by the other diagonal. So notice that this diagonal here is bisecting. So the diagonal that's between the two congruent sides bisects the diagonal that's between the non-congruent sides. So that means WU and UY are congruent. And it also means that XZ is a perpendicular bisector, which means it is going to bisect angle X and angle Z. So if I told you this whole angle up here was what? Let's just say it's 80 degrees, then each part of this would be 40 and 40. And if this one down here was, let's just say the whole thing was 20 degrees, then obviously this would be 10 here and this would be 10 here. So in kite, K-I-T-E, what is the measure of angle T and E? So notice here again that K and T are congruent, so this one over here would be 100. And then the way that we're going to find E is recall that all the angles inside here add up to be 360 degrees. So the sum of all the angles is 360 degrees. So we are going to add them all together. I don't know why this is coming in out of order, but so we're going to add all four of them together, and we're going to get that they add up to be 360. Well, when I add 100 to 100, that's 200, plus 20, that's 220. We're going to subtract the 220 from 360, and that gives us 140. So this angle up here would have been 140 degrees. All right, so this next, okay, so with number 14, it says ABCD is a kite, AE is 5, CD is 13, BC is 7.1. Then we're going to find the other leg. So it says AE is 5, so I'm going to put 5 here, and that means I know that EC is also 5, because those two parts are congruent because BD bisects AC. And I also know that AC has got to be 10 because 5 plus 5 is 10. Then let's go on and keep labeling. So CD is 13, which means this side is congruent to that side. Those are consecutive sides, so those will both be 13. Also, BC is 7.1, which means that AB would be 7.1. So we can then say that AB is 7.1 again because BC was 7.1. Then notice here that we have a right triangle. I want to bring this to y'all's attention. And I know that again because all these angles in here are right angles, right? So it's saying that DEC is a right triangle, right? Well, we have two legs and a hypotenuse in a right triangle. So DE is one of the legs, EC is another leg, and DC is the hypotenuse. So we're going to do leg squared plus leg squared equals hypotenuse squared. So we don't have DE, but we do have EC, that was 5, and we have CD, which is 13. So then we get DE squared is equal to 25, plus 25 is equal to 169. I'm going to subtract 25 from both sides. That gives us 144, and hopefully all of that when we take the square root of 144, it equals 12. So our next one says, in kite, K-I-T-E, measure of angle K is 40. So that means this measure up here is 40 degrees. The measure of angle E is 130. That's this one over here. The measure of TE is 15. That's already marked. XE is 9, and KE is 41. So we know a couple things here. Obviously, we know that consecutive sides are congruent, so this would be 15 here. We know that this would be congruent with this, which would be 41. And we know that this is congruent with this, so both of these would be 9. Also, we know that opposite angles are congruent here. So if E is 130, then that means I is 130. And we should be able to find t by subtracting the other three angles from 360. So let's work through the math here. So we know that I and t are congruent, so that's means I is 130. The measure of t is equal to 360 minus the other three angles. 130 plus 130 is 260, plus 40 is 300. 360 minus 300 is obviously 60 degrees. So that means this angle down here would end up being 60 degrees. And recall that if I asked for you for those parts, I would have 20 and 20 and 30 and 30 down there, okay? Then it's asking us for Ix. Ix is equal to IE, so that means it's 9. Ik is, now to find Ik, Ik is equal to Ek, so that's going to be 41. And IT is equal to ET, so that's going to be 15.